In this topic, we're going to talk about quadratic functions and transformations. We've already talked about a quadratic function, which is of the form y equals ax squared plus bx plus c, where a cannot equal 0. There's another form for writing quadratic functions. We'll talk about it in more detail at another point in time, but for now I introduce it to you. It's called Vertex Form. Y equals a times the quantity x minus h squared plus k. Here is the basic, most fundamental quadratic formula. Y equals x squared. When we graph it, if I make a table of values and I use the x values, -3, -2, -1, 0, 1, 2, and 3, I'm going to find out that some of the ordered pairs that lie on this curve are at -3, 9, because that's what you get when you square a -3, -2, 4, -2 or -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. You notice that the y values started to repeat themselves. That's because when you square a negative or you square a positive, the result will always be a positive. So here's -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And the curve is this U-shaped, which we refer to as a parabola. Sorry, my pen's not working well. Some of the things we notice is that if I were to draw a line smack dab through the middle of this parabola, and it's vertical, it cuts the parabola directly in half. We call that line the axis of symmetry. Because if you were to fold a sheet of paper over that line, the one side of the graph would lie on the other. The axis of symmetry, since it's a vertical line, has an equation. All vertical lines have the equation x equals, and whatever x value it hits on the x-axis. So this particular vertical line goes through 0 on the x-axis. All parabolas have a lowest or highest point, depending on if they open up or down. This particular parabola has a lowest point, and that lowest point is at 0, 0. That is known as the vertex. We also call it the minimum. The minimum value we usually say is y equals 0, because that's the y coordinate of the vertex. So in vertex form, that y equals a x minus h squared plus k, we say that the vertex always occurs at h comma k. So if the vertex is at 0, 0, and then I plug it into this equation, I get y equals a x minus 0 squared plus 0. But as you know, if you add 0 to something, it doesn't really matter. If you subtract 0 from something, it doesn't really matter. So we end up with y equals ax squared. The value a in front of the x squared is going to change how wide or how narrow the parabola is. So let's look at another function in this form that's not quite y equals x squared, but is actually y equals 1/2 x squared, and see what happens to this table of values. So I'm going to draw this table right next to it. We're going to plug in the same x values just to start off the problem. The 1/2 is going to change the y values. So when you plug -3 in for x, you know that negative 3 squared is 9, but 1/2 of 9 is 4.5. When we plug in negative 2 squared is 4, but 1/2 of 4 is 2. When we plug in negative 1 squared is 1, 1/2 of that is 1/2. We plug in 0 squared is 0, 1/2 times 0 is 0. But as we already know, the cool thing about parabolas is that these values I already know. It's because of that symmetry caused by the axis of symmetry. So now when I go and graph these, instead of negative 3, 9, I'm going to graph negative 3, 4.5. I'm going to graph negative 2, 2, negative 1, 1/2, 0, 0, 1, 1/2, 2, 2, and 3, 4.5. Notice what happened to the parabola. It got wider, didn't it? The only thing that's the same between these two parabolas is where the vertex is. The axis of symmetry is also the same. Notice that the axis of symmetry always goes through the vertex. So wherever the vertex lies, the axis of symmetry will be x equals the x coordinate of the vertex. Now let's talk about what would happen if instead I wanted to graph y equals negative 1/3 x squared. Well, two things are going to happen. First of all, when we multiplied x squared by 1/2, it made the parabola wider than the y equals x squared. So the 1/3 is going to make it wider. But I wonder what the negative might do to the function. Well, what's going to happen is when I make my table of values, and I use the same ordered pairs, my negative 3 squared is 9. 9 times 1/3 is 3, but because of that negative in front, it's going to become negative 3 here. Negative 2 squared is 4. 4 times 1/3 is 4/3, but the negative in front is going to make it negative 4/3. That's approximately negative 1.3 repeating. Negative 1 squared is 1 times 1/3 is 1/3, but the negative in front makes it negative 1/3. The nice thing about plugging in 0, 0 times anything is 0. And you already know, if I find those three values, then the three y values on the other side of 0 are going to be the same. So my points are going to be at negative 3, at negative 1, or I'm sorry, negative 2, negative 4/3, which is going to be a little past negative 1. Negative 1, negative 1/3, 0, 0. 1, 1/3, negative 1/3. 2, negative 4/3, and 3, negative 3. And there's my parabola. Not only did it make it a little bit wider, but it also flipped it. We say that the negative in front of the value being multiplied by x squared reflects over the x-axis. You can tell me that it flips. I'm all right with that, but the proper terminology is that it reflects over the x-axis. So let's put this together. For the general parabola y equals ax squared, if a is actually greater than 0, we didn't look at this case, but this is what will happen. It's actually going to make the parabola narrower. We say that it stretches it. When a is between 0 and 1, as the cases we looked at what happens when a is a half, what happens when a is a third. It makes it wider, or it compresses, or sometimes we say that it shrinks. It just depends on which textbook you're using. And the other thing we found out is what happens when a is negative. Well, when a is a negative number, it reflects over the x-axis, or it flips it over. When that happens, when the parabola opens up, I want you to notice that the vertex was at a minimum. Minimum meaning the lowest point on the graph. But when we reflected it over the x-axis and the parabola opened upside down, the vertex was now at the highest point. We call that the maximum. All right, let's go back to our y equals x squared, because there's some other things that can happen to the parabola other than getting wider, narrower, or flipping over. Let's look at what happens when instead I look at y equals x squared minus 5. All right, let's make our table of values. Negative 3, negative 2, negative 1, 0, 1, 2, and 3 is what we're going to start with. So negative 3 squared is 9, 9 minus 5 is 4. Negative 2 squared is 4 minus 5 is negative 1. Negative 1 squared is 1 minus 5 is negative 4. 0 squared is 0 minus 5 is negative 5. Let's make that more like a negative. 1 squared is 1 minus 5 is negative 4. Hey, look, I bet it's starting to repeat itself. I bet the next answer is negative 1. 2 squared is 4 minus 5 is negative 1. And I bet the next answer is 4. So let's look at where this got graphed. So negative 3, 4, negative 2, negative 1. No, it's going to be down there. Negative 1, negative 4. 0, negative 5, 1, negative 4, 2, negative 1, and 3, 4. What just happened to the graph of the parabola? Well, it looks like it moved down. Matter of fact, it didn't just move down, it moved down 5 spaces. Huh, that's interesting. If I subtract 5 from the original function, it appears to move it down. I wonder what would happen if instead I did y equals x squared plus 2. All right, let's do the same thing. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. Negative 3 squared is 9, plus 2 is 11. Negative 2 squared is 4, plus 2 is 6. Negative 1 squared is 1, plus 2 is 3. 0 squared is 0, plus 2 is 2. 1 squared is 1, plus 2 is 3. Oh, I think it's repeating. There we go. If you start to notice the pattern in how the quadratic graphs are created, you don't have to fill out the entire table. All right, so negative 3, 11 is a little bit off my chart. That's okay. It's up there somewhere. Negative 2, 6. Negative 1, 3. I'm having problems. 0, 2. 1, 3. 2, 6. And 3, 11. Oh, that's kind of interesting. Look at what happened to the graph. It won't even graph for me. Let's see. There we go. That's better. It appears to have moved the graph up 2 units. Oh, wait a second. Okay, so if I subtract a value from the original function x squared, it appears to have moved the graph down. If I add a value from the original to the original function, it appears to move the graph up. All right, let's summarize. So, when your original function, oh, by the way, f of x is the same as y, we'll call that ax squared. So, if you add a value to the original function, we'll call that, call it c, it's going to move the graph up c units. And if you subtract a value from the original function, it appears to move it down c units. All right. So now we've moved the graph up and down. The only thing we haven't talked about yet is how do you move the graph left and right. So let's do that. How about y equals x minus 4 squared? Now this one's different because if you think about order of operations says you have to evaluate what's inside the parentheses first before you can square it. So if I go back and I use my same x values for right now, and we'll talk about translations in a different way in a few minutes. So I plug in negative 3 for x. I get negative 7. Negative 7 squared is 49. Oh God, I'm not going to be able to graph that on my graph. That's fine. We'll just keep going. Negative 2 squared is 4. Oops. You got to tell me I did this wrong. Try that again. No, I did it right. Never mind. All right, let's try that again. Negative 2 minus 4 is negative 6. Negative 6 squared is 36. Negative 1 minus 4 is negative 5. Squared is 25. 0 minus 4, negative 4 squared is 16. 1 minus 4 is negative 3 squared is 9. Ooh, I'm starting to get things that actually lie on my graph. Hold on a second. I need to erase what my cat stepped on. Okay, let's try that again. 2 minus 4 is negative 2. Squared is 4. Right. It's not gonna. All right. And let's try this one and see if it works. No, I can't get this to work at all. Nothing's happening. I can't get anything to write. Now I'm moving that. There we go. Sorry about that. Then 3 minus 4 is negative 1. Squared is 1. So I need some more points that lie on my graph. So let's try 4 here. 4 minus 4 is 0. 0 squared is 0. 5 minus 4 is 1. 1 squared is 1. And then I guess if I use 6, 6 minus 4 is 2. 2 squared is 4. And then if I use 7, 7 minus 4 is 3. 3 squared is 9. So now I actually have some ordered pairs that lie on my graph. So I have 1, 9, 2, 4, 3, 1, 4, 0, 5, 1, 6, 4, and 7, 9. And there's my parabola. Hey, look at what happened. If I move to inside the parentheses, an operation on the input x, it seemed to have moved this particular parabola 4 units to the right. Oh, minus 4, and then I'll move 4 units to the right. Sometimes students don't like that. They don't like that it says minus 4. They think that minus, well, that's to the left, right? Well, if you think about it like this, take what's in the parentheses and set it equal to 0. Let's try that again. X minus 4 equals 0, so x equals 4. That basically says move it to 4 on the number line. Well, to move it to 4 on the number line, you have to move it to the right. And the shape of the graph looks the same. Nothing about the parabola looks different other than the fact that I moved the whole thing to the right. Okay, so now let's do this. What happens if I try to graph y equals x plus 5 squared? I'm going to start skipping steps now. If it's inside the parentheses, it's going to move the graph left to right. So I'm going to take what's inside the parentheses. I'm going to set it equal to 0. Well, my pen doesn't write. And I'm going to solve for x. That says move the vertex here to negative 5. So it's going to be there. Well, what does the shape of the graph look like? Or you can do it this way. You can say, okay, so I know the vertex is going to move to be at negative 5. So I probably need a couple points around negative 5. So maybe negative 4, negative 3, and maybe negative 6 and negative 7. And that'll give you enough points to get the shape of the parabola. So negative 3 plus 5 is 2, 2 squared is 4, negative 4 plus 5 is 1, 1 squared is 1, negative 5 plus 5 is 0, 0 squared is 0, negative 6 plus 5 is negative 1, negative 1 squared is 1, negative 7 plus 5 is negative 2, negative 2 squared is 4. So I know it's going to be at negative 3, 4, negative 4, 1, negative 5, 0, where I already have a red dot, negative 6, 1, and negative 7, 4. I could have done more points, but you get the idea. So now let's summarize. 4y equals ax squared. If you add a value to the input, not to the original function, to the input, which means it's inside a set of parentheses, you're going to move it to the left, c units. Makes it look like I wrote kunits. It's not, it's c units. If you subtract a value from the input, it's going to move your graph to the right, c units. Nothing about the shape of your graph changes other than it's been shifted. Let's put these two shifts together inside of a quadratic equation. We get this thing called vertex form. H is what's going to shift the graph to the left or right. And it depends on if it has a plus sign or a minus sign. And we just learned if it has a minus sign, it's going to the right. And if it has a positive sign, it's going to the left. Outside, the plus k is going to move the graph up or down. Then the number in front being multiplied, a, I should use a different color, a is going to tell me if the graph gets narrower or wider, and if it reflects, if it's negative. So now I can tell you what this graph is going to look like if the equation is written in vertex form. That's why vertex form is very useful, and we'll talk about how to actually write an equation in vertex form at another time. Now here's how it works. Because of vertex form, the reason it's called vertex form is because I can tell you right away what the vertex is. The vertex is at hk. Now, be very careful. The vertex in this parabola is at 4, negative 2. Why isn't it negative 4, negative 2? Look at the original equation and notice that the original equation has a minus sign in it. So that means that h must have been replaced with a 4. If h had been replaced with a negative 4, it would have become a positive. All right, so if I draw myself a basic little graph, I already know that the vertex is at 4, negative 2. I know it starts here. Does it open up like a U or an upside down U? Well, is it being multiplied in front by a positive or a negative? If it's a positive, the parabola opens up. If it's negative, it opens down. The other thing that I know is because of where the vertex is, I know that this is the axis of symmetry. So if I want to make a table of values now, I'm going to make the table of values around where the vertex is. So I'm going to put a 4 here in the middle. I'm going to put 3 and 2 on one side and 5 and 6 on the other. Then I'm going to go fill out my table. So when I plug in 2, 2 minus 4 is negative 2 squared is 4, times 3 is 12, minus 2 is 10. 3 minus 4 is negative 1, squared is 1, times 3 is 3, minus 2 is 1. 4 minus 4 is 0, 0 squared is 0, times 3 is 0, minus 2 is negative 2. 5 minus 4 is 1, 1 times 3 is 3, minus 2 is 1. And since this is symmetric, I bet that answer is going to be 10. So now I know it goes through 3, 1 and 5, 1. And I know it goes through 2, 10, wherever that is up here somewhere, and 6, 10. So it gives me a general idea of what the parabola looks like. Or I can do it this way. I can say that the vertex is at 4, -2, and it's been shifted, or I can do it this way. So I can say in vertex form, it tells me how this graph has been shifted. It tells me that it's been shifted 4 to the right. That's what this tells me. This tells me it's been moved 2 down. And this tells me that it's narrower than y equals x squared. And if you look at the graph, hey, look at that. Must be right. And the axis of symmetry must be the equation x equals 4. Remember, the axis of symmetry is vertical. All vertical lines have the equation x equals whatever value the line passes through on the x-axis. All right, let's talk about this one more time. This is called vertex form. And vertex form is very useful because it tells me how the parabola has been transformed. First of all, I can tell you that the vertex is at 1, 3. Remember, inside the parentheses, if there's a minus sign, it's the opposite. Think about it like this. X minus 1 equals 0, so x must equal 1. So I know the vertex is at 1, 3. I know the graph has been moved to the right 1 and up 3. Inside the parentheses tells you left or right. Outside the parentheses, up or down. This number in front tells me that not only is the parabola narrower, but the negative means it's been reflected over the x-axis. So now, if I go and make myself a little table of values, I know the vertex is at 1, 3, so I'm going to pick 1 as my middle x value. So I probably need 0 and -1 on one side and 2 and 3 on the other. And then I can make myself a quick table of values by plugging in the numbers. So -1 minus 1 is -2, -2 squared is 4, times -2 is -8, plus 3 is -5. 0 minus 1 is -1, -1 squared is 1, times -2 is -2, plus 3 is 1. 1 minus 1 is 0, so 0 squared is 0, times -2 is 0, plus 3 is 3. I bet these other two numbers on the other side of the vertex must be 1 and -5. So now if I go and draw myself a quick sketch, I know that one of my points is at -1, -5, 0, 1, 1, 3, 2, 1, and 3, -5. And this must be what the parabola looks like. And that's how we transform graphs of parabolas.